cube. Okay, let me do it again. 60 minus 10 times by 20 times by 50 plus by 7.5 power 3, 37.5, or 37.5 times 10 to the power minus 6 meter cube. Okay, so the shear stress at now our point B is equal to Vz over Iyy multiplied by 57.5 times 10 to the power minus 6. And then the thickness again is perpendicular to the shear flow. Geometry of the shear flow is 0.02. So this is equal to 57.5 pound minus 6 divided by 0.02 is equal to 2.875 times 10 to the power minus 3 Vz over Iyy. Let me do it again. 57.5 power minus 6 divided by 0.02. 2.87. Okay. Then we have to find at point A, right? The point A, we use the non-thin wall analysis. And the thickness now, so the thickness is perpendicular to the or in non-thin wall, the thickness is perpendicular to the direction of the shear flow. So the thickness now is 0.06. Okay, 0.06. So at point A now, QZ or QY at point A. Now we have to consider, I'm going to draw the perimeter of the area that we have to consider. So we have to consider this entire area now. This entire area now. First movement of area. Okay, like this. Right. So we know QA and QB. So this will be twice of 57.5 times 10 to the power 3 plus. So the width is 60. Right. The depth, so it's 120 over there. It's also 60. The y by 60 divided by 2. Okay. So this is good. 2 times by 57.5 power 3 plus by 60 times 60 times 60 divided by 2. It's equal to 57.5 power 3 times 2 plus by 60 times 60 times 60 divided by 2 is equal to 223 times 10 to the power 3 millimeter cube, or 223 times 10 to the power minus 6 meter cube. Let me do it again. 57.5 power 3 times 2 plus a 60 times 60 times 60 divided by 2, 2 to 3. Good. Okay. So now we come on. Now we find our shear stress at point A. So this is equal to Vy over Izz. And then we're going to multiply by 223 times 10 to the power minus 6. And then the thickness is 0.06. Okay. So 223 power minus 6 divided by 0.06 is 3.71. 7 times 10 to the power 3 Vz over Iyy. So now this time is different, right? Now this time point A has the highest stress. Okay, so we realize that tau max will occur at point A. Okay, so we know that tau max is 75 times 10 to the power 6, which is equal to, let me check, did we use 75 before? We did. Okay, so this is equal to 3.717 times 10 to the power minus 3. Okay, then we have Vz over Iyy. So from here, we know that Vz over Iyy is equal to 75 power 6 divided by 3.717 power minus 3 is equal to 20.178 times 10 to the power 9 Newton per meter for. Let me do it again. So 75 power 6 divided by 3.717 power minus 3, 20.178. So therefore, the shear stress at point B is equal to 2.875 times 10 to the power minus 3 multiplied by 20.178 times 10 to the power 9. So 2.875 power minus 3 times 20.178 power 9 is equal to 58.012 times 10 to the power 6 Pascal. Let me do it. 2.875 power minus 3 times 20.178 power 9. 58.012. And then the shear stress at point C, which is equal to 0.75 times 10 to the power minus 3. It's 0.75 multiplied by 20.178 times 10 to the power 9 is equal to 15.134 times 10 to the power 6. Let me do it again. Okay. So as I said, you have to be careful if we flip the direction. Okay, you realize that when you flip the direction, the maximum shear stress is at point A, no more at point B. Okay. Okay, I'm going to end my lecture here. I will stay back. If you have any question, you can ask to clarify anything. Okay. Thank you for your time.